Hello, dear guys. Hello, dear friends. I hope everybody is fine. Today, we want to talk about a very fundamental question. We really want to understand it. The framework of this question will fall. It will exclusively be inculcated in the framework of science. But we can touch some of the philosophical arguments to this title. And the title goes like the origin of everything. If I start with an argument, imagine that tonight every star in the sky it suddenly disappears. Every star in the sky disappears. No moon, no sun, no galaxies, and no planet Earth. Everything disappears. Even the atoms, no atoms, and no space. And to conclude this no, I will say no time. I mean, nothing. Everything disappears. Now, ask yourself a question that has puzzled humanity for thousands of years, for millions of years. Why there is something instead of nothing? This is not merely a scientific question as I started with this argument. And as I approached, it's not merely a philosophical question as well. It's not merely a religious question as well. Maybe it's perhaps the deepest question that human mind can ask. Human mind can go with. So, friends, I welcome you all, and this is something that we're going to talk about. We're going to talk about the origin of everything. And today we'll embark on an extraordinary intellectual journey. A journey from the smallest particles that have ever been discovered to the largest structures in the cosmos, in this universe. A journey, as I can say, a journey through science. I will connect philosophy with it, and maybe the mysteries that still remain unresolved. By the end of this discussion, by the end of this argument, by the end of this video, you may not have all the answers, but I should say that you will see the universe with entirely new eyes, with entirely new sensation, with entirely new feeling. So let's begin with an argument. Let's begin about the human quest, the quest of humans for origins. And let me tell you, since ancient times, humans have looked, as I repeatedly say, they have looked upwards, and some of them have wondered. Not all of them have wondered. And where did all this come from? The stuff that used to be visible to the civilizations that have lived on this planet. And I can say that every civilization asked this question. Every culture asked this question. Every generation asked this question. The question. Even a child naturally asks this question. Even though there is an environment surrounding this child, but the child has that sense that when he looks into the sky, and scientists ask it professionally. The kids don't ask it professionally. Talking about philosophers ask it endlessly. The question never disappears. This question arises in a child who's few years old looking into the sky. Because deep within this is a desire. There's a desire to understand our place in reality. And this desire may not be the part of the animals. It may not be the part of the other species that are living on this planet. I will take you on another imagination. Imagine there is a traveler. Say, for example, there is a traveler, and this traveler is crossing a vast desert. And for days together, he sees nothing but sand. Then suddenly he finds a beautiful watch lying on the ground. Would he think the watch assembled itself? Probably not. He would immediately wonder. He will be astonished. He'll be surprised. He will immediately wonder. And he'll say, who made it? Who made it? Why? Why was it made? How did it get here? The universe creates a similar sense of wonder. The more we learn, the more we understand, we have more questions. More questions emerge as we understand more and more. Now, what does science tell us about it? Science, modern science. Modern science suggests that the observable universe has been expanding for billions of years. It's expanding in all directions. And when scientists trace this expansion, when they go back to this expansion in the backward direction, they arrive at unimaginably hot and dense state. Hot and dense earthly state. This is often called the Big Bang model, very popular in all formats of life, in all domains of life. And here you notice something important. And what do we notice here? The Big Bang Theory does not necessarily answer why reality exists. Why is it so that you have this hot and dense pot? No space, no time, nothing at all. It primarily describes how the universe developed from its earliest observable stages. The stages of radiation, then we know all the theory about that how matter came into existence. So science is extraordinarily powerful here in describing the nature of reality, the existence of these stars and galaxies. But science has also limits. And to be frank enough, and recognizing those limits is itself a sign of scientific maturity. There are flaws, there are lacunas, but accepting those lacunas makes it mature. Then we have the cosmic timeline. Now, let's go with this argument. Let's briefly travel through this cosmic history, as is reported in all formats of our lives. The earliest moments, the formation of fundamental particles of nature. So these are the earliest moments. And then over a period of time, we have the birth of atoms. And we have the birth of atoms, and then we have the appearance of stars, the formation of galaxies. Then when we move on, then we can trace it back to the birth of planets, and then we can move on to the emergence of life on the planet Earth. And then you have the appearance of conscious beings. And these conscious beings are capable of asking questions. And think about that. Think about it for a moment. Over billions of years. And then you have questions. The universe became aware of itself through these conscious observers who are asking questions. This may be one of the most astonishing ideas in all of science, in all of scientific outcomes. Now, a step further if I go, and I talk about the miracle of the night sky. Now look at the night. When you stand up outside your house in a dark night, you look at the night sky. Every star is a giant nuclear furnace. There are many stars. They are larger than our sun. Some of the stars are so massive that millions of Earths could fit inside them. Millions of Earths. You can imagine the size of these stars. And yet those stars are only tiny points within enormous galaxies. And there are countless galaxies. The number can not be exactly calculated, but but the calculation can be such that their number is very, very large. The scale is it's beyond our imagination. What am I trying to tell here is, I would like to take you to the library. That may better take us to the origins. If you imagine entering a library, and this library is containing trillions of books. Now, each book contains, say for example, billions of letters. You have trillions of books, then each book has billions of letters in it. Now imagine discovering that every letter is arranged according to the precise rules. Won't you be amazed? Would you not be amazed when you will see this? When you will see this order, when you will see this genius? The universe is similar. It possesses remarkable order, remarkable, precise, accurate. And our mathematics describes it. Our mathematics describes it and physics predicts it. Yet, its ultimate origin remains mystery, unanswerable. You cannot fit the answer to answer this question. So what we have this universe has a language, and this language is mathematics. So universe possesses the language of mathematics. Now, why does mathematics work so well? Why can the equations that are written on paper, how can they describe the distant stars? Why can an abstract symbol predict the real phenomenon? A symbol, F, force, a real phenomenon in an equation. And many great scientists have regarded this as one of the deepest mysteries. The effectiveness of mathematics is itself a profound puzzle. It's a tool provided. It's a tool discovered. It's a tool that takes us to all of these arguments. Now, if I go into the world of atoms from here, everything around us appears different. Whatever the surroundings is there, what we have is, in front of me right now, there are mountains. I can see some of the trees outside the window. And there are rivers. There are different things that we encounter that are surrounding us. And there are animals. There are different kinds of animals. And of course, there are human beings. Now, all of these things, all of these different things that we see, they're all built from those atoms. And inside atoms are the smaller components. And inside those components are even deeper level of structures. Like we have protons, neutrons. The deeper we look, the reality becomes more strange. Or I can say we have stranger reality. Strange reality. Stranger the reality becomes. Why should I lead you from here? Is I should lead you to what we call as quantum mysteries. And to be frank enough here, quantum mechanics is among the most scientific, I should not say scientific, I should say most successful scientific theory ever created. Yet, it challenges the common sense. Now, how it challenges the common sense? Particles, they behave like waves. They wobble. Their behavior is like a wave. And they appear to have probabilities. Probabilities appear to be more fundamental than that of the exact predictions. Observations plays a surprising role, because here you have the collapse of the wave function. You come up with just one reality. The universe at its deepest level is far stranger than everyday experience suggests us. The way we walk, the way we play games, the way we build our houses, the reality is not like that. And then there is another corner, and that corner goes to relativity. And it was Albert Einstein. Einstein transformed our understanding of reality. And according to Einstein, space and time, they are not two separate entities. Space and time, they form a unified structure. And what they form, as we know, they form what's called gravity. Or we can say mass and energy, they influence the structures. Or we can say gravity is no longer merely a force, as was predicted by the genius Isaac Newton. Now gravity becomes geometry. Reality is more elegant than anyone imagined, to a level we can sense of. Let me take you to another domain. Let us assume that we have an ocean, and we call it the fish in the ocean. Imagine a fish that has lived entire life under water. It knows nothing else. It only knows water. And one day it asks, what is water? Everything around it is water. It has experienced water only. Yet, because it is immersed in it, the fish barely notices it. Perhaps we are similar. We live inside reality itself, but maybe some of its deepest features are difficult to recognize. They are difficult to recognize because they surround us constantly. as I chose this example, it takes us to the question of nothingness. Now, what is nothing? Because our origins tend to stand there. Can true nothingness even exist? If absolutely nothing existed, there would be no matter. It's not possible. There would be no energy. If I connect it with the real arguments, there will be no space. And there will be no time. So what does it hint us? Even there will be no laws. There will be no possibilities. There will be no probabilities. Because we understand what nothing. This question certainly pushes both science and philosophy to their limits. A complete constraint to the philosophy, a complete constraint to the science. Now, what we know and what we don't know. Science has certainly achieved extraordinary success, but still many mysteries remain as realities that cannot be explained. Like you have an example of, say, dark matter. What is dark matter? Okay, then we have what is dark energy? Then you have, why do the laws of nature behave their present form, the way they behave? Why? Why does reality exist at all? So these are the fundamental questions. These are the questions of life. These are the questions of thinkable life. And these remain open questions. And that is what makes it exciting. That's what makes it extraordinary. Mystery is not a weakness of science. Mystery is what basically, I should say, it drives humans towards discoveries. It drives humans towards inventions. So what could we conclude out of all this is humility. We must praise humility before the cosmos. The more we learn, the more we realize now, the more we realize how much remains unknown. True knowledge produces, I should say frankly, it produces humility. It does not produce arrogance, because there is a lot that we don't know. The greatest thinkers often became more humble as their understanding increased, as they understood more and more. They lost their arrogance. They lived the life of humility, because reality is deeper than any single explanation that you can have on this planet. Now, I would love to conclude this. I would like to conclude all that I was trying to share with you people, with my friends. What we did basically is we began with a simple question. And the question was why there is something instead of nothing. This was a very starting question. For all that, I bored you for a long time. I'm sorry for that if you're bored. What we did, we explored, we talked about stars, then we talked about galaxies, we talked about atoms, and then I quickly tried to take all my arguments to the quantum mechanics. Because I teach quantum mechanics and I love teaching quantum mechanics, even though I don't understand it fully, but it makes me feel beautiful. We talked about space and time, and somewhere we encountered mathematics and the mysteries that still remain, the mysteries that are unanswered. Yet, the greatest lesson from all this stuff, from all that we talked about, may be the universe is not only a collection of objects are there. It is also an invitation to wonder why, how long, how far, how big, how small, an invitation to think. It's an invitation to search whether one approaches these questions through science, philosophy, or faith. The journey itself enriches the human mind.